All right, here's a problem involving specific heat. So the idea is we have this equation that Q equals M times C times delta T, where Q is how much heat it requires to raise the temperature of something, M is the mass, usually in grams, C is the specific heat, typically in joules per gram degree Celsius. It's how much heat it takes to make 1 gram go up by 1 degree. And delta T means the change in temperature, typically in degrees Celsius. So I want to figure out how much heat it takes to warm up 75 grams of water from here to here, and this is water specific heat. So it's really just literally plugging in. The mass is 75 grams. The specific heat is 4.18 joules per gram degree Celsius. And the change in temperature from 18 to 32, we just subtract them, and I get 14 degrees Celsius is the change, and so I just multiply those out. So 75 times 4.18 times 14, and I get 4,389. And the units, if this is in grams, the grams will cancel, Celsius will cancel, and I'll be left with joules. So this is how much heat it takes to raise the temperature of water by that much in joules. Sometimes you might see the specific heat written in joules per gram Kelvin. It doesn't make a difference because the idea is a change in Celsius is the same as a change in Kelvin. For in other words, 18 degrees is 291 Kelvin, 32 degrees is 305 Kelvin, and so the change is still 14, regardless of whether it's in Celsius or Kelvin. And so that's just sort of how the Celsius-Kelvin temperature scale works. But anyway, that's it. That's a basic version of this problem. There are more complex, but just make sure you understand how this equation works and where you plug in. So until next time, I am Derek Genova. Have a delightful day.